Today we're going to be taking a look at this older HP MediaVault 2-bay NAS and how we can install somewhat of a modern operating system on it. This is the MediaVault Pro, and this one in particular, you can see we've got an MV5100 series. So there were two generations of the HP MediaVault that were released. There's a generation 1 that came out around 2006. There was a generation 2 that came around 2008. This is a generation 2 unit. And there was kind of a entry level and a pro model, a couple pro models actually. So there was the MV2120, which was just the regular baseline model. And then there was the Pro MV5020. And then this is actually an MV5140, which is kind of middle of the road there. And then there was also a really high-end MV5150. So if we flip this over and we take a look at the bottom here, you can see this was actually a 5140. So this would have came with two 500 gigabyte hard drives installed in it. The 2120 and 5020 came with one 500 gig drive, and the 5150 came with two 750 gig drives. And these ranged anywhere from, I think, like $400 to $500 all the way up to $700 to $800. So this specific model was probably around $650. Now, I did pick this up off of eBay. I got this for about $35 to $40. And I got it mainly just to kind of play around with it, because I never had a MediaVault NAS. I've never been able to get my hands on one, so I was able to secure this, which is really awesome. Now, when this released, it did have a capacity limit of 4 terabytes. That was mainly the operating system they were running. And we're going to open this up. I'm going to show you the inside. This is actually rather unique. But if we flip this open, you can see we've got one hard drive bay in here, but there's actually two bays inside here. One is essentially an internal drive that you don't swap out. Put the operating system on it, put it in there. And the other drive is kind of your typical hot swappable bay that actually the generation after this continued to use these same drive bays. So if you watched my DataVault X310 video, this should look familiar because this is actually the predecessor to that lineup of NASs. So this came out first, and it's essentially a baby version of that with a SoC instead of a conventional x86 or x64 processor. And we'll talk about that here in a minute. Moving along the side, you can kind of see it's got kind of that same form factor. It's got that magnetic door on the front. It's kind of got those two hard drive LEDs that come through there. We've got a USB 2.0 on the front. But moving on to the back, there is no integrated power supply on this. So what they did is they actually leveraged a HP laptop power brick. 65 watt power brick. And so that's what we have here. This is the official brick that came with these. So that is the HP DC 359A, which you can see right there. And so typically when you buy these, it's just the chassis. Usually they don't have a power supply with them. Fortunately, HP used that power brick on tons and tons of laptops. Those power bricks are plentiful. So I did have to pick that up extra. However, these are only like $5 to $10 for the power bricks. They're relatively cheap. Taking a look at the back of this unit, there is basically vents up here for the fan. There is a fan that sits in here. But we only have one USB 2.0 port. We have a gigabit Ethernet. We got that power plug, that DC jack for the laptop power brick. We've got power button, and we've got Kensington lock. You're going to notice that very minimal input output. Now, unlike the DataVault and the MediaSmart PCs, this does not have that internal I/O port to plug in VGA output. It does, however, have a serial console connection that you can tap into. So you can tap in to the TX and RX lines on that and kind of get a pseudo console output. However, this is running a SoC, or a system on chip. And so kind of what that means is you have a integrated, it's not technically a real like x86 processor, you have an ARM processor. This one actually has an Orion, so it's a Marvell Orion ARM-based processor, but like I said, it's an SoC. So what that means is the Ethernet, the USB, the processor, they're all kind of on one chip together. So a more kind of what you would see in some of the lower end single board computers today. That's kind of what the inside of this looks like. And once we get this off, you'll kind of see that. Now with these units, you don't have to take the side panel, the top panel, or anything off at all. You actually just undo these 4 screws. And you may be asking yourself, as I take this apart, you might be asking yourself, well, how can we actually load a different operating system on this if we don't have any type of video connection capabilities? Well, there is a recovery mode on this. And the way the recovery mode worked is you plug it into Ethernet, you put it into recovery mode, and then you would actually be able to load a recovery image over the network, and it would install it to that first hard drive slot, that internal hard drive slot. And we're able to tap into that, and we're going to be able to load Debian onto this. It's going to be a little bit unique, and the important thing is that this uses U-boot. It doesn't have like a conventional BIOS, and there's very specific configuration that's needed, so you can't just throw any operating system you want on it. Plus, this is a really old ARM processor that isn't supported in the latest versions of most operating systems. It's not even supported in the latest version of Debian anymore. They kind of did away with it. Not that they removed the functionality, but this unit only has 128 megabytes of RAM. So very little. It's not upgradable at all because of it being an SoC. And go ahead and pop that cover off there. And what you'll see down here, no heatsink, anything like that. So you've got an actual SoC on the inside. This is the serial connection on the front I was talking about that you could tap into. And you can kind of see your 2 hard drive slots on that SATA backplane there, which isn't really a backplane. It's more of just a mount with kind of a pass-through. So there's actually 2 SATA cables that come out of the back of that, plug into the main board there. Same thing with your power connection there. It all comes into that main board, and then you also have a fan slot. If you look down in there in the back, there is a little fan there. Helps keep everything cool. And that's pretty much all you have on the inside. So what we do is we basically slot in 2 hard drives. Now you're going to notice there's really no mounting mechanism for this first hard drive. But the way it'll work is you actually just grab a screw kit, and you grab 3.5-inch hard drive screws. So we're just going to need 2. Let's go ahead and grab 2 of those out of there. And all we do is, now I'm going to be using an 80 gigabyte hard drive for my operating system. One of the big reasons I picked this up, I've had this 80 gig hard drive sitting around forever with no real use. I don't want to consume a slot in a lot of systems for it. So I decided this is going to be great to run the operating system on. And then I'm going to just be running a 3 terabyte Seagate Barracuda in that kind of that hard drive caddy pseudo hot swappable slot there. So we're going to go ahead, and for me, I'm not going to be running this in any type of hot swappable mode. Probably going to run these in LVM, so the unused capacity on this will be available to that. But what we want to do is we want to face SATA ports that way, and we're going to put a screw here, and we're going to put a screw here. And all you're going to do is you're just going to screw them all the way in. And what's going to happen when you do that is those little screws, the head of the screw will ride down into these grooves, and it'll keep it so that you're not putting any pressure on that port at the back there. So put the screw there, then put this one in on this side. And now we're just gonna tilt this up. We're gonna slide this down. And we're gonna just line up the screws with that. And we're gonna notch it in. And then once you slide that in, you can see it doesn't really move at all. And it's perfect. And then take your other drive, pop open the caddy here, and just notch that in, swivel the other side out, and you are good to go on your second drive. So then you can just slide that straight down in, push it, lock it, you're good to go. Now at this point, you can put that cover back on. We actually don't need to have this cover off at all, because we're not going to be tapping into that serial port at all. Let's go ahead and pop this up, put this in. Now, as I'm reassembling this, we do have, basically we have two operating system options. We can either run, and we can restore the factory HP firmware onto this, which would run the factory kind of HP Linux version that they had on these. But we're not going to be doing that. We're going to be running Debian instead, which is our other option. Now, with Debian, we are going to be able to have a full functioning operating system. However, this is a Orion ARM processor. It is a, as I mentioned, it's a Marvel SoC. So technically it's in the classification of an ARM 9, but it's only 500 megahertz. We only have 128 megabytes of RAM. It is not an ARM v7. So what that means is a lot of modern 32-bit applications that are built for ARM will not work on this. In addition, we're going to have to make some operating system tweaks so that we can make it kind of usable with the 128 megs of RAM. And that's going to kind of be our bottleneck there. So even though we're installing Debian, we're not going to be able to run Open MediaVault on top of it. We're going to have to set up a Samba share manually, which is no problem. It's relatively easy to do, but you will have to remote into this. This setup is going to be more on the technical side of things. It is a little bit more involved than your typical setup. So I went ahead and removed the caddy. We're going to leave the caddy out first. Let's get the operating system installed first. Now, in order to do that, there are some tools that we will need. I'm going to hop on over, and I'm actually over on Lee Devlin's website. So Lee Devlin is one of the architects who designed this unit. So he used to work for HP, and he actually runs a website all around the MediaVault. And so this is the generation 1, this is the generation 2, the 2 is what we have. And he's got a plethora of documentation on his website around this unit, how to tap into the serial, basically everything. Being one of the engineers on the project, he has a lot of kind of insider info on how it was programmed, how it was built, how it was designed. He had a big hand in that. So definitely recommend hopping on over to his website if you're interested in learning more about the MediaVault. He's got an entire section over there dedicated to just the MediaVault with a knowledge base, different ways you can hack it, how to do a lot of things with the HP operating system, as well as the power supplies, power supply replacement, as he mentions here, MV2. Their official part number was that DC359A, 65 watt, 18.5 volt. And I'm not going to go over everything on his website, but he does have tons of information over there. In addition, there is also over on Sirius, however you pronounce it, .com, they actually have a tutorial on how to get Debian up and running on this, but more importantly, they have links to all the files that you need. So in particular, there are kind of two methods to do this. On Windows, you can use the official HP firmware app to kind of flash the firmware when this is in recovery mode. However, I'm going to be going the Linux route. So if you're on Linux, and I'm actually going to be using a Raspberry Pi for this, there is an app called UPHP MVault, and you can download and install, and this will allow it to basically send the image to this device on your network. So the only thing you need is you need a Linux box that is running on the same network as the MediaVault is going to be plugged into. And then you're also going to need the official Debian netboot image. So Debian actually maintained an official image for this system. You can see we're over on archive.debian.org. And one of the caveats here, the latest version you can run that supports this unit is going to be Debian 10. So it's a little bit of an older version of Debian. However, it's the newest version that works with 128 megabytes of RAM. So that is our limiting factor here. It's nothing that's in like the operating system or the kernel. It's really that the kernel needs that much RAM in order to operate. So we are going to be limited with a little bit of an older version. And you can see this is an ARM-L processor. So again, it's that Orion 5X, which is an ARM9. And so we just need to grab this netboot image. First thing I'm going to do is I'm going to grab this Debian file. I'm going to right click, copy link address. We're going to come over to our PuTTY session where we made it in. And we're going to do a wget on that. And then we're going to do a sudo dkpg-i on UPHP MVault. Enter our password. And that's going to install UPHP MVault. So now if we run UPHP MVault --help, we can see it's installed. Okay, and it tells you that it tells you about how it's tied to U-boot, and it's specifically for the HP MediaVault, the MV2, which is the generation 2. Now we need to grab the netboot image for Debian. So I'm going to come over here, I'm going to right click, copy link address, and then we're going to go back over there. We're going to do a wget, paste that in, hit enter. All right, now all we have to do is we just need to do UPHP MVault and pass in the parameter of our netboot.img. Once we launch that command, you can kind of see it's saying waiting for broadcast beacon packets. So now what we need to do is we need to plug in the power, and then we need to grab either a paper clip or I got a little thumbtack here. There is going to be on the front of this unit, there's going to be a little pinhole here that's going to access a reset button, or really a recovery button. And you'll be able to hear or feel the press on that. And what we need to do, we need to make sure that that utility is still running and listening. And then supply power. We need to hold in that reset button or recovery button. At the same time, hold in the power button until this screen tells us that it is sending the file. We're going to plug in the power in the back here. And then go ahead and swivel this down a little bit. And I'm going to press in on that pinhole. Feel it click. And then I'm going to hold in the power button. I'm going to hold both in until I see that file sending. There we go. So now we can see it's sending the file. I can release both of those. And this will take several minutes, but what should happen is it should send the file, the system should then reboot itself, and then it's going to go through a lot of initialization phases trying to start up the installer, which we're then going to be able to SSH into. But we're not going to do that until the lights on this unit, so our satellite, should become blue. Alright, and so that app just terminated, so that means that this unit should be booting up, and we should get a blue SATA, which we just got. So that means it is starting to boot up into the installer. We can see our IP address was 192.168.70. So after a few minutes, we should be able to open a new PuTTY session, go to that IP address, hopefully, and be able to connect to the installer. So it's not up yet, so we're going to give this a couple minutes. What should happen is this flashing light should turn solid blue. So that activity indicator should go solid blue, and that's our indication that we are able to SSH into the system. Essentially what's going to happen here is it's going to launch the installer, and that installer is going to expose an SSH server within it that's going to allow us to connect to it and actually run through all of the install scripts as if you were just sitting right in front of it. It had a monitor hooked up to it, and we're able to have keyboard and mouse monitor, everything like a normal PC setup. The only difference here is we're essentially doing a remote configuration session without having something like IPMI or anything like that. It's still blinking, however, we do have that solid satellite. So I went ahead and checked my router, and it looks like it has an IP address. Let's see if we can connect to it. It actually did get a different IP. So we're going to do 192.168.1.11. And it looks like we can connect to it. Now, the username is going to be installer, and the password is going to be install. And there we can see that it actually is launched. So let's bring this down here a little bit. And we're going to hit enter to start the installer. We're going to hit United States. Now, we actually need to go back here. So one of the things that you need to do with this, because we're running an older version of Debian, when it prompts you for your Debian archive mirror country, you want to do enter information manually. And here we're going to type archive.debian.org. We have to pull this from the archive because it's no longer the active repo. Continue. So again, we're installing Debian 10. I believe the current version is 12. So we're a couple major versions behind here, but this is going to give us a full working Linux environment that we can use on this system. So as I mentioned earlier, it's kind of, you only have two choices. Either run with the HP OEM Linux distro, or you can basically get yourself an unlocked Debian distro. And so that's what we're running with today. The apps that we can run are going to be somewhat limited. We're not going to be able to run a storage provider on this. Unfortunately, storage won't work with this unit, and I haven't tried to compile it manually. I may try that and see if we can get it running on this. But as of right now, it looks like storage probably won't work. In fact, when I look at the requirements, they say it does have to be an x86 or x64 processor to run, and it does require quite a bit of RAM. When I look at it running in RAM, it's using around 512 megs, and we only have 128 on here, so probably not even going to try it. I'm mainly going to use this system as a local network backup. It's kind of going to be a backup to my backup. So I already have Synology NAS running. Some of my files that I want to just have a failsafe, an additional backup of, I'm going to store on this unit. So this won't be going out to the internet for anything really. It'll all just be on my local network. and because we are somewhat limited on those apps and we are running an older version of an operating system that isn't going to have a lot of security patches anymore. Now, you do need to be super patient with this installer. This is going to take a really long time. Chances are this installer is going to take upwards of an hour, maybe 2 hours, to actually run through end to end. Again, we're loading a full Linux distro on a 500 megahertz and 128 megs of RAM system. Once we get through kind of this initial setup, then we're just gonna let it run, and then once it's done, I'll kind of show you guys how I configure it. But we'll let this go ahead and launch the disk configuration so we can confirm we can image the disk. Okay, it's gonna ask us for our language. We're gonna select English, United States. And it's gonna ask us to enter a root user password. So we do have to specify a password for root. And we need to confirm it. And now we need to create basically our primary user that we're actually gonna log in with. Once we set up that user, it's gonna ask for a time zone and central. And this is the part where it's going to detect the hard drives and launch the kind of partition manager. And I'm going to be, even though this is only an 80 gigabyte hard drive, I'm going to be setting this up with an LVM so that when we put the second drive in, we can just expand that main OS drive. We've got really two options there. We can either create it as a separate mount point if we want to keep it isolated from the operating system drive, or we can extend the operating system drive with the second drive using LVM. Being only an 80 gigabyte operating system drive, you may not want to extend. You probably isn't worth it to only gain access to, 70 gigs or so. You may just want to treat your second drive as its own independent drive in case your primary drive fails for any reason. Again, 2-bay NAS, so you are somewhat limited on what you can do. Alright, so I'm going to say use entire disk and set up LVM. And you can see it's got that drive there, so it is that 80 gigabyte drive. It's the only drive we have in there right now. And I'm going to say all files on one partition. And it's going to say there's an existing LVM. Do you want to remove? Yes. This will wipe everything on the drive. And it's going to tell us, it's going to format it as ext2. Again, we're on Debian 10 here. Go ahead and say yes. And now it's going to ask us what capacity we want. I'm just going to leave this as the default. Just going to be, on this drive, is going to be, just shy of 80 gigabytes. All right, and it's going to basically tell us how it's going to format it. Go ahead and say yes. And it's going through and it's creating the partitions. So you can see it is creating an ext4 for the file system. And it's going to name that volume group Debian-FG, or Debian-VG rather, for volume group. Alright, now it's installing the base system. This, like I said, this is going to take a really long time. So once this is done, we're going to complete the setup, reboot the system, and then we're going to SSH into it from the computer. And I'm going to show you guys how to configure some things to make it work with modern operating system and to allow that operating system to kind of use more memory than what it would by default. And also how to install some monitoring utilities and how we're going to bring it into our home lab dashboard. The installation of the operating system is now complete. So we went ahead and let the system reboot, then we turned it off. We put in our 3 terabyte hard drive in that top drive bay using the caddy, and then turned on the system. We are now SSH'd into that system. So we hop on over and we do a cat/etc/os-release. We can see we are running Debian 10 Buster, and that all looks good now. So now if we do an lscpu, you can see we've got that ARM v5 tail. So we've got an ARM-L processor in here. Now if we do df-h, you're going to notice here that we've got our 80 gig LVM in that main drive. We haven't extended that with the second drive yet. However, if you take a look here closely at the /run, you can see that we only have, right here on /run, 13 megabytes. Now this /run, this is kind of the RAM that the kernel will use for executing specific things. One of those is daemon reload. So if you ever need to do a systemctl daemon reload, which can run frequently if you're doing updates, if you're upgrading, if you're installing packages, if we run this, you will notice this error. It will say refusing to reload, not enough space available on /run. Currently 10.4 megs are free, but the OS has a safety buffer of 16 megs. So if we run a free-m, we can see that we're actually only using 21 megabytes of RAM to run the OS, which is nice because we only have 128 megabytes in the system. That reflects as 121 megabytes usable. The OS install did create a swap for us that is around 355 megabytes. So we can extend this run partition, and that's what we need to do in order to be able to stably use the system. And what we're going to do is we're going to bump this up to around 20 megabytes. So by default, it uses 10% of whatever available capacity your system has. So in this case, because we have 128 megs, we're using about 20. We've got around that 100 meg free. It's taking 10% of that and only allocating that to run, but the system requires 16 megs. So we can extend that though, because we know that we have the capacity to do so. So to do that, we're going to do a nano on /etc/initramfs-tools/initramfs.conf. Now, this is the conf file, as you can see here. So this is the configuration file for initramfs, which is kind of that file system that runs in RAM. And if we scroll down, you're going to see this run size equals 10%. And that's where it's getting that 10% number from. We can change this to 20M. That's going to do a static 20 megabytes. So you do that, hit Control X, Y, enter. And now we need to do a update -initramfs-u. That's going to go ahead and update it. And so you can see it's generating that new initrd.img file for our Marvell processor at /boot. And then this may take a minute or so. Again, we're running on older hardware here, so you do have to be patient with some of these commands that run. But once this is done, we're going to reboot the system. And then what we should see here is instead of this being 13 megabytes, it should be 20 megabytes. Once that command's done, it's going to tell you it's installing the new U image. Now we can go ahead and issue a reboot command. And this is going to reboot the system. Now we need to wait for it to come back up. Once the system's rebooted, we can SSH in, log back in, and we're going to do a df-h. And if we take a look at that /run mount point, you can see it now has 20 megabytes instead of the 13. So if we do a systemctl daemon reload. It should work this time without any errors. Which it does. So now we can do an app update -y and apt upgrade -y. Let's go ahead and run those. Now, depending on if you've ran this before or not, this may take a while. So be patient with this. This is Debian 10. So it is an older one. There's not going to be a lot of updates. The installer should have installed most of the updates there. But we are running on very minimal hardware, as a reminder. So we've got that Marvell SoC. So we've got system on chip kind of set up here. And then we've only got that 128 megs of RAM. So just be patient with this. And then once this is done, we are going to install a couple apps using apt install. Okay, you can see that that is now finished. And so we're going to do an apt install. I'm going to install 3 things. First one is going to be docker.io space. And then we're going to install shell in a box. So shell in a box is going to give us a web-based way to log in the system. So instead of doing SSH through PuTTY, we'll be able to go to the IP address of the server in a web browser and do SSH through a web interface. And then the last one is called Glances. Now, Glances is kind of a monitoring tool that also exposes APIs. And this is going to allow us to, through a web browser, kind of see everything that's running on the system, monitor drive usage, CPU usage, memory usage, swap file usage, all of that. But it's also going to allow us to bring all of that information into a dashboard app like homepage, which we're going to be doing as well. So we're going to do an apt install on those 3 apps. And just give it a minute to validate everything. And then it should start to go through. You can see it's 175 megs of additional space. So it is going to use a couple hundred megs here. So just give it time. There are a lot of packages that this has to install. Glances runs on Python. So if you don't have Python 3 and all of its libraries and utilities installed, it's going to go through and install all of those dependencies. And again, because we're dealing with that ARML architecture and a very slow processor and very minimal RAM, it's got to do a little bit at a time during those install processes. So just be patient with it. Once that's done, let's run docker ps-a to verify Docker is up and running. It is. We don't have any containers running, but that is purely what we expected here. So we're good there. Now let's do a systemctl status show in a box. And that is running, so we're good there. Now, by default, Glances does not set up a service. So we need to create a service file and copy and paste some content into it. Over on Glances GitHub, they actually give you the file that you can create. So they give you all the content you need here. And we want to start it as a web server. So we're just going to copy this example. Go ahead and hit copy here. And over here, we're going to do a sudo nano etc systemd system /glances dot service. We're in as root, so we don't need to do sudo there. And then we're going to paste in the contents that we copied from their GitHub. Do Control X, Y, enter to save. Now we're going to do a systemctl enable Glances. And now we're going to do a systemctl start Glances. It's going to go ahead and start it. Now we can do a systemctl status. Validate that it's up and running. It is not up and running. So let's run glances-w and see if we have an installation there. It looks like Glances can run fine. So let's do, we're going to do a where is Glances. And we can see that it is actually in user bin /Glances. So let's go ahead and copy this. And we need to go back to the service file. And we need to update the path. So depending on what operating system you're on, the path might be a little bit different here. So we're going to go ahead and do this since we're on Debian. The Debian package installed it into user bin. Do Control X, do Y, enter to save. Now we need to do a systemcl daemon -reload. This is one of those examples where we really needed to, update the available RAM that the operating system can use. Because had we not been able to do the daemon reload, we would have had to reboot the whole system just to do this activity. Now we can try to start the service again. And if we do a status, now it's running. So it was just that it was pointed to the wrong path because the package for Debian installs at a different location than what Ubuntu does. So no big deal there. We got that up and running. So now if we pop over a web browser and let's validate that shell in a box is working first. So if I do 192.168.1.70, the IP address of the system, we need to do HTTPS on this. We're going to get a little SSL warning. We hit advanced proceed. And we're presented with our login for our Debian server. Now we can right click here and we can switch to white on black. Make it a little bit easier on the eyes. And we can also turn off secure mode if we want. So that is working. And the other thing we want to check on HTTP 61208. Let's see if our Glances dashboard is working here. Okay. So this is the out-of-the-box Glances dashboard that you kind of get. And so this will have all your info for you. So it has the operating system you're running, the architecture, the kernel, your CPU, your memory, your swap, all your drives, everything. Now, this is at a quick glance processor. It gives you everything you need. However, we want to take this and we want to pull this into my homepage dashboard. So how do we do that? Let's hop on over to homepage. This is my homepage config file. And I already have some other NASs in here, but we're going to add another one. So since we've got this one set up now, I'm just going to copy previously what I had on my NAS 3, which is a HP MediaSmart, which is actually the successor to this unit, I believe. We're going to do NAS 4 here. And this is going to be the MediaVault. And it is a MV 5040, I believe. We'll go ahead and plug that in. And so our terminal, this is going to be our link to shell in a box. I'm just going to update the IP address here. And same thing with the site monitor. That'll tell us if it's ever offline. And then on system, this is going to point to Glances. So we're going to do 70 here, 70 here. And then we need to switch to version 3. And we're going to do 70 so on the widget. And then on the disk widget, once again, we're going to do 70. And we are going to do a version of 3. This is the API version for Glances. The package that is installed as part of Debian 10 is an older version, a little bit of an older version. And with that, we need to make sure we're using the older version of the API, which is why we're switching to 3 on the specific system. Okay, and we've got our processes, and we've got our containers. So now, go ahead and save this. And now if I hop on over to my dashboard, it's actually refreshing. I do have a handful of servers in here, so it does take a bit of a minute to do that initial load. And you can see, so in here I've got like my network, I've got my Synology NAS, I've got the DataVault X310, I've got the MediaSmart, and we now have the MediaVault MV504. 5040 rather. All right, so we can see that it's pulling in the system, it's pulling in the processes. There's no containers running, but it is not pulling in the disk. So let's check the disk config real quick. Okay, so I had the wrong disk config here, so it should be fs for file system : / go ahead and save that, bring this over here, and when you click off of one of the containers it should refresh. And if we scroll down, once it brings in the stats here, we should have our disk, which we do. So you can see it's got that 80 gigabyte. Again, we haven't extended it yet with that second drive. We're going to do that here in a minute. But we now have, we've got our terminal. We can click on this. This will actually bring up Shell in a Box, where we can log into the system from here. We've got system. So this has our current CPU usage, memory usage, and swap file usage. We can also click here, and this will take us to that dashboard, where if we want to see more detailed snapshot of everything running on the server right now, we can do that. And then we've got the disk, which we covered. We also have the processes. Now the process is going to be the top 5 processes running. And if we had containers, anything running in Docker, they would show here. So we're now able to remotely manage and monitor kind of everything that we've got there. So next step is to get that second drive working and create a Samba share. So what I'm going to do is I'm going to do a fdisk-l. This is going to list the drives, and we're looking for dev SDB. So we're going to do a wipe fs-a on dev SDB. I didn't have any file system on there, but if I did, it would wipe it. And now if I do a PBS, we can see we just have that SDA5 partition. So I'm going to do pv create /dev/SDB. That's going to create it. And then I'm going to do a VGS. I'm going to do a VG extend, and it's called Debian-VG, and we're going to extend it with dev SDB. So you'll notice right now the free space is 0 and the volume group size is 74 gigs. Let's go ahead and extend that. Now if we do a VGS again, we can see we now have 2.73 terabytes free. So now we can do an LVS. We can see that we've got that volume there. Let's just do a df-h to get the path of the LVM. It's going to be this one here. Now we can do an LV extend, paste in that path, and then we're going to do -l plus 100% free, all lowercase, -r. This should take that storage space that we just added to the volume group and extend the logical volume for it with it. And also, because it's mounted to the root and the operating system's currently running under that LVM, it's going to also resize the file system online so that all of that space immediately becomes available without a reboot. Once it's done resizing, if we do a df-h, we should see that we've got that 2.8 terabytes available now across that root drive. And if we hop on over to Glances, you can see this now shows 2.76 terabytes. If we go back to our main dashboard, whoops, wrong screen. If we go back to that main dashboard and give this a second to re-grab the stats, you can see it now reflects that 3 terabyte total, 2.9 terabytes free. We've got 1.2 gigabytes used. It is doing a little bit of rounding there, so the numbers aren't going to be spot on down to the gigabyte, but it's got the figures there. So now the last part that we need to do is create a Samba share. So to do that, we need to install the Samba service. We're going to do an apt install Samba. And this is going to be so that other devices on our network, such as Windows PC, can see the share and read and copy files to it over the network. And it's got quite a bit of dependencies, so we're going to let this install. And then once it's done installing, we're going to do a little bit more configuration. And then it may prompt you if you want to install the DHCP client package to support Wins. I'm going to go ahead and say yes. Once that's done, the Samba service should be up and running. Now we want to create a folder. So we're going to do mkdir/data. This is where I'm going to store all the data. This is going to be the folder that we end up sharing out. Now, we also want to create a user. This part is optional. I'm just doing this for display and validation purposes, but we can do user add-m space. I'm just going to call it user. And then we're going to give that user a password. Okay. Now we need to grant that user access to the Samba. So we need to do SMB password space -a space and then the username. Now we need to edit the Samba share file. So we're going to do nano etc/samba/smb.conf. And now we want to go all the way to the bottom here, and you're going to see some sample shares that are already set up for you. But we're just going to go all the way to the bottom, and we're going to create a new one. So I'm going to call this data. We want to put that in square brackets. Then our path is going to be /data. And then read only is going to be no. And guessed okay is going to be no. And a valid users, we're just going to put user in here. It's going to be the only account that can access this. Again, just for demonstration purposes, I'll come back and put my real user in here later. And then we can do Control X, Y, enter to save. And now let's do a systemctl restart. SMBD. And let's just do a systemctl status on SMBD. Let's make sure it's up and running. It is. So now let's see if we can access it. Come over here and we go to the IP address of our system. We can see we have a data folder now. And we are prompted for credentials. Let's enter user. Let's enter the password that we selected. And we get access is denied. So even though we have a local account, we haven't granted ourselves access to the Samba group, so we're unable to access that. So let's hop back on over and let's add our account to the Samba group. So that's going to be SMB pass WD -a user. And it's going to ask us for a new Samba password. I'm just going to enter the same thing. We put on the user account. And now you can see it added user with a username of user. We'll hop back on over here. Hit OK again. You can see we've now been granted access into that. So if I come over here, let's move into /data. And let's just create a folder called temp. We come over here, give this a refresh. You can see that temp folder is now there. Attempt to delete the temp folder, and we are able to. And let's just validate that we can create a file. We can. So everything is working just as I need it to. So at this point, we have a full functioning NAS. We can map this as a network drive if we need to. We've got a data folder. We also have a user folder, just kind of like a home folder for that user account. This will, by default, give you kind of like profile folders you can work with, or you can choose to not expose those through the Samba config. But for me, I've got this data folder. This is what I'm going to map and kind of use over my network. So at this point, everything is up and running. We've got our dashboard configured so that we can keep an eye on how the system's performing. And so far, everything looks great. So that is the HP MediaVault. In particular, this was the MV5040. But pretty much any of the second gen MediaVault lineup, all the hardware is identical with the exception of the hard drive capacity.